Well, thank you all for coming. My name is Chris Guiterman, PhD student in School of Natural Resources and the Environment, also in the Tree Ring Lab. And it's exciting for me to present kind of the results of my work collaborating with the Navajo Forestry Department on this project to try to assess the climate sensitivities of their forest lands. So a little background on the Navajo Forestry Department. They're charged with managing all of the forests and woodlands in the Navajo Nation, which is 5.4 million acres. If that were a national forest, it would be by far the largest within the lower 48. There's only 2 in Alaska that surpass that amount of acreage. The commercial forest land component of that is about 600,000 acres, and it's really centered here in the Chusca Mountains and the Defiance Plateau, which is really where my work is focused, because that's kind of the center of their attention, because they have a low budget. There's 4 full-time foresters and a bunch of crews. And what they're tasked to do is really important for the Navajo people. I mean, the Chuscas are not only kind of the water tower of the Navajo Nation, there's also a lot of life going on up there. This is a landscape where traditionally people go up in the summer, they spend the season in their sheep camps, they have their livestock, and there's a lot of other traditional forest uses that are wrapped up in kind of the culture of the Navajo people. And so protecting this landscape is a big task for these foresters to do. Background on this study, the inception of it goes back a little more than a year and a half. I went up to the Navajo Forestry Department to present work that I'd been doing in the Chusca Mountains to them since 2011. They asked me to come up and talk about what I had found, and I brought up all these tree ring samples and cores and stuff, and I kind of let the tree rings do the talking. So, they got to see how old some of these trees were, and I think that was really impressive for them. And then I was given the opportunity to, just kind of stand back and say, this is what I do. What do you need? What can I do for you? And they had a range of ideas. These are 3 that I pulled out as kind of things that I think I can approach. So one, they're interested in the vulnerabilities. They're really concerned about how vulnerable their forests are to climate change. They see these changes coming down the pipeline. They're reading about it and everything. And so they want to know, what does that mean for us, for our landscape, not just the planet in general. They also want to know about productivity. They have some data on productivity that I'll show you, but they really want more information, whatever information I can give them. And since I look at tree rings and measure tree rings, I can get productivity. They also, like I said, were interested in how old the trees were. So they said, give us more information on age structure out there. We don't have a lot. So what else can you add to that? So I came back to the lab in the spring and kind of mulled this over with my mentors at the Tree Ring Lab, and we came up with this pretty simple study design that I think capitalizes on their knowledge base already. So the idea was to go into forest plots that they already have established. This is a network of continuous forest inventory plots that they use to kind of assess their timberlands. And we'll just core trees on those plots. So it's a gridded data set already out there ready to go, and we can select trees off those plots to core. So we measure the tree rings, and we quantify productivity. We can take the chronologies and do kind of basic dendroclimate assessment to figure out what the climate drivers, the seasonality and different types of climate factors are in promoting growth in those trees. And then, we have these tree cores already aged. We can do age structure from that as well. But this is use-inspired research, right? So this goes back to them. I'm interested in all of these things for sure, but this is more kind of geared toward them. The science part of this is stepping back and assessing this. This is a really great piece of work that our colleagues, led by Park Williams, produced. It's called Forest Drought Stress Index. So it's looking at the climate factors that are driving tree growth on a huge regional scale. This is Arizona, New Mexico, parts of California, Colorado, Utah. So it's a really major look, very widespread look at what's going on with tree growth across the Southwest. And what they found is because of the influence of temperature on vapor pressure deficit, which is basically, think of it as the demand for moisture that the atmosphere has, like a sponge that's sucking moisture out of the soil and out of the trees. Because of those factors, when you project the drought stress index forward, it crashes. That means that by 2050, the average level of drought stress will be worse than the worst years of the worst droughts in the last 1,000 years. It's a grim picture. It's not a good thing going on in a forest. And so this is the kind of thing that the foresters are like, how is this going to play out on the landscape? And so what we want to know is, how will it play out? How representative is this to kind of the broader forest area? Because without getting into the nuts and bolts of it, this is built from very selective trees that are cored specifically to pick up a climate signal. But what does it mean for the rest of the forest land? And then we can kind of figure out from that what areas of the forest are actually buffered against these kinds of changes going on down the road. So what areas are less sensitive and why? And that's really kind of where this project is headed. So we did our field work in June, and I had a really great field crew. I was joined by, here's Dan here, Dan Ferguson of CLIMAS. This is Galen Gudenkoff, who's an undergraduate in the geography program. These two guys are crews with the Navajo Forestry Department. This is Herman Yazzie and Tim Jim. And this is Kathy Covington, the Navajo Regional Forester for the BIA, who's always been a major supporter of this project. It was great to get her out in the field for so long.
And the dog. And the dog.
And the dog, oh yeah, my dog hiding her head. She's not very photogenic.
It's not the best picture.
Yeah, well, it's hard to get us all lined up. So I can't emphasize enough how great it was for me to spend time with these two guys, with Herman and Tim, out in the woods. I've been wanting to spend time with foresters from the Navajo Forestry Department in the woods for a long time. And so just being out there with them, they grew up in this landscape. They've been working it as foresters for several decades now. We'd walk into plots and think, oh, I remember this plot, or I asked them, there's stumps over there. When was this logged? Like, 1920s. They just knew so much. They had such a deep understanding of this landscape that, I can only attempt to approach. So just being with them was great. And that's part of this fellowship, right? That was my plan, get out with these guys. So I learned an awful lot from them. Fieldwork's an adventure, right? So Dan got up on the truck and snapped this picture while we're like totally lost, trying to figure out where the heck we are, how the heck to get to the plot.
3 of us were lost, 2 of us knew where we were. The guy pointing knew where we were.
Well, yeah, okay. So we're trying to find the plot. So it was just fun to kind of share in this adventure with them. And they taught me how to navigate the maze of roads. There are no signs or anything up there. So that was really cool. And then they worked really hard. They cored a lot of trees for me and, just were upbeat the whole time and excited into the project and just constantly loved doing what we were doing. So it was just a pleasure. In all, we sampled 7 different plots. We cored over 100 trees and we took back 222 cores to the lab. Kyle Miller, who works at the Triving Lab, is one of Connie's former graduate students, helped me date and measure all of these tree cores. And then in October, I got to go back up and present to them. So what follows from here is kind of what I talked to them about, and I'll give you kind of bits and pieces of that. Another benefit of the CLIMAS money, the funding, was I was able to do this. This is a huge slab of ponderosa pine that they had in their wood yard for the last maybe 3 or 4 years, and they've always wanted to do something with it. So on our way back from the field, we threw it in the back of the truck. We barely lifted it into the back of the truck, really heavy. We hauled it back, and one of my student assistants helped me sand it up, and I dated it 1690, so it was surprisingly old. And then I brought it back up and spent some time with the guys with this thing up on the table, just looking at it, talking about the different patterns and its age and the story of the tree. And so hopefully next year we'll turn it around and we'll offer it to the Navajo Nation Museum in Window Rock as a display piece. So that was really cool to be able to contribute that back. So in my presentation to the Navajo foresters, I try to kind of get their heads back into the woods. I mean, the ideal way to do this would have been for us all to hop in trucks and drive up into the forest and start talking about the forest there. Just not feasible right now. Hopefully in the future we can do that. So I showed a lot of pictures like these from the different plots, and we walked through every single plot to get them there, because these guys are experienced enough. You show them this and they're like, I got it. I know what that forest is. I know how it lives. I know how it breathes. And so I just kept talking about the different kinds of plots we were sampling, what was there, what we could see. And then, at that point, I was like, okay, now we'll start in on some data, right? Because the data is a little more difficult to grasp. So I started with age structure, because it's kind of the easiest thing to understand, and it's also one of the more interesting components when you're curious about tree ages. We looked at graphs like this, where the black, which is normally red, is ponderosa pine. So these are time series, the distribution of the number of trees recruiting in any given year, or really 5-year bins. So, without getting too much into the nitty-gritty of it all, there's differences among the different plots. So like this plot has a few old ponderosa pine, and everything that's coming in under it is Douglas fir. So it's this kind of conversion. It's changing its composition. This plot has, a couple old, very large ponderosa pine trees, and then a whole bunch of younger ones, the youngest trees that we cord, because they have to have a minimum diameter before they can be cored. So they're very fast-growing, very young trees. So completely different from this in terms of age structure. And we talked about the different things. What's going on with the patterns? Why are there trees recruited in the 1850s? Why in the 1900s, or kind of this first decade of the 1900s, et cetera? And then we talked about, what does it look like with these big trees? Because we think of old trees in the landscape, right, as the really big ones. It's not necessarily true. So these are a couple of examples of old small trees. They're pretty tall, but they're not growing very fast. And so we talked about kind of the characteristics of that and what it means in terms of climate and management, et cetera. And then I'm a big fan of, the record holders. So this is the oldest tree on a CFI plot that I've recorded so far. That smudge down the bottom is Dan kneeling in front of this big old tree. It dated to the 1600s. And it's a cool tree, so as we sample more plots, we'll find some older ones, I'm sure. And then the current record holder for all of the Chusca Mountains is this big old guy that happens to be in the campsite that we like to stay in. Ponderosa pine, it dates to 1481. I worked really hard to make sure I hit the pith as low down as I could get it, so I don't think this tree is going to get any older by recoring it. Probably won't bother. But it's 534 years old, and it was pretty cool. I showed this picture, we talked about this tree, and immediately 2 or 3 of the guys were like, oh, I know a tree that looks like that. And one guy ran and grabbed an aerial photograph out of somewhere. I have no idea where he got it from. And pointed, and he's like, you see that turn in the road? It's right there. I was like, all right, mental picture. I'm going to try to remember where that was. So they're into it. They want to help me find these big old trees. They're curious about them. So that's just great. That's the kind of thing I'm looking for. And then we get into the tree growth. So again, we've measured the tree cores, and we can look at growth. But you got to remember, this is what they're starting from. This is over 40 years of data from their fixed area plot. So they go and they measure these trees, and they can calculate and quantify growth. This is a really impressive data set. Not a lot of forest areas have this long-term repeated plot measurement. But that's it. We can't talk about stand dynamics. We can't talk about management or the effects of climate with this data set. It's just not detailed enough. So when we core those same trees, we can do this. This is now the average growth for every tree on the plot in every year, going back well into the 1800s and back into the 1700s in some cases. So we're really looking at a lot more information in terms of drought effects and effects of wet periods and stuff like that. And there's also really clear differences between the plots. So just my 2 end members, right? This is the one with the older trees, really high growth variability. Every year just swinging up and down, with some low frequency variability, but a lot of interannual variability. This plot's totally different. There's almost no interannual variability. It's what we call complacent. It's growing fast. It's not growing with much variability. Until you get out at the end here, it has these kind of low frequency swings to it. I think that's related to these young trees coming in, but we haven't totally figured it out. These plots are, experiencing the same climate, are not that far apart, maybe a few miles, but are completely different in growth dynamics. So that's the kind of, okay, here are our end members. What are we learning from that? We also talked about the non-growth years. So these are years in which the trees literally just didn't grow a ring. And the time series for each plot. And the number of trees, the higher the bar, the more trees did not grow a ring in that year. So what stands out is 2002, a really rough year to be a tree in the Chusca Mountains. 42% of our trees that we sampled did not grow in 2002. And you can see, like on this plot, only 1 tree did have the 2002 ring. It was tiny, tiny, tiny. On this plot, only 2 trees were missing that ring. So there's something totally different going on, how these things are experiencing the climate that's driving this distribution of missing rings. Get into climate sensitivity. So we take those chronologies that I showed you, and I just basically do simple correlations with PRISM data from the same area. So gridded climate instrumental data set. And then I can map it out. So I do it for every plot and map it out back on the landscape. And we can see differences again among the plots. So here's that plot with the high interannual growth that I said that's got to be climate sensitive. It sure is. Its correlation to March to June precipitation, so spring before the growing season, is very high, very strong. So it needs a good setup to be able to grow well. If it's a dry spring and winter, it's not going to grow. Whereas there's that plot with the young trees that doesn't have a lot of variability. It doesn't really care what's going on in the winter. It's going to grow. It's going to grow fast. When we look at summer precipitation, you see things kind of change. Suddenly this complacent plot starts to kind of pick up a little correlation. But these values are all really low. It wouldn't even map out on this side. So the summer precipitation, so that's current summer of the year that trees are growing, is not that important for growth. And we kind of know that from all the work that we've done in the Southwest. So this is kind of more the normal pattern. But what we're curious about is the variability between plots and landscape characteristics. When we switch to temperatures, this is maximum temperature, average maximum temperature for June and July, and this is vapor pressure deficit. They follow each other, but there are some differences between them. But again, that plot with a lot of interannual growth is really sensitive. If it's hot and dry in June and July, this plot, these trees are not happy. So they're not going to grow very well. It's a negative correlation. Whereas this plot, again, it doesn't care. It can be dry in the winter, hot and dry in the summer, and it just grows. It doesn't care. There's something buffering it from those effects of drought. Pretty much the same story with VPD. So when I pitched this project about a year ago to the CLIMAS board, I said, I got this idea. I don't have any support for it. I really just want, a nugget of credibility with the foresters so I can go forward with the project. Since then, I've been really happy to find that I have more support and we're going to keep going. So in April, I found out that I was a recipient of EPA Star Fellowship to do fire history work in the Chuscas with the Forestry Department. I was able to kind of wrap this project up in that too and get a little extra support. But then more than that, we got a grant from the BIA. I was invited to submit a proposal in May, right before we went into the field, for this project. In fact, the review board of all the BIA regional foresters met via a conference call the first day we were in the field. So Kathy Covington was asked to kind of talk about our project. We happened to be near a cell tower, so she's got us on speakerphone, or got them on speakerphone, on the plot. We're coring trees around her. And they're like, okay, describe your project. So all she had to do was say, we're here, we're doing this, there's these people, and I think we were a shoo-in after that. So it was a pretty special experience. I don't ever expect that to happen again. So now with this additional support and a very flexible committee, thank you, Connie, I was able to make this project a full dissertation chapter, but more importantly, really give a lot more back to the Navajo Forestry Department. Instead of these 7 plots, we're going to have 30 plus and have a lot more data going forward. So a long list of people to thank. Dan Ferguson especially for being my mentor, an expert tree corer in the field. I think he hit pith on about half his trees. It was really impressive. And it was fun to share all his great photographs that he took out in the field. And all these other folks too. But